Welcome everybody to my talk about Gradle 3.0 and beyond. Actually, I cheated a little bit and changed the title of my talk now to be Gradle Heading 4.0. The reason for that is that when I handed in the talk uh, a while ago for that presentation, Gradle 4.0 was not that close, but now we are closer to Gradle 4.0 than we are to Gradle 3.0. I talk a little bit about that later on. Um, My name is René Gröschke. I'm working as a principal engineer for Gradle for more than 5 years now, doing mostly working on Gradle Core or Gradle Cloud Services, which I will present later on, and did a lot of consulting and engagement in the last couple of years, helping customers all over the world with implementing Gradle, using Gradle, etc. You can reach me via Twitter or email if you have any further questions regarding Gradle or to that talk, or grab me after my quick presentation here. Um, so what will we look into? That won't be an introduction talk, so I won't cover the essentials of Gradle. So I assume you have some experience or just seen it, at least Gradle in action. I picked one of my favorite latest features in Gradle, and we talk a little bit about the next features, so things we're currently working on. I have some demos prepared to show you some of those features in action. And yeah, afterwards we can have a Q&A session. I am willing to answer questions you have around Gradle ecosystem or things about my presentations or any other Gradle related stuff. And I brought stickers. Hooray. Um, So for those of you not using Gradle in production yet, maybe a quick Gradle management summary. So Gradle is a multi-purpose software automation tool. That's what we like to name it. You can use it to build, automate, and deliver better software faster. So it's written in Java, so it's cross-platform. We test it against all different kinds of operating system, but also against different Java version. So if you have to use a Java like IBM SDK, you can do that, and we test against that. So we are language agnostic. So it started with supporting Java, and that's still our main um, use case, I would say. But we also support different native languages and all different kinds of languages in that polyglot world that's kind of necessary now. It's Apache 2 licensed, and yeah, Gradle itself consists of the build tool known as Gradle, but now we added some cloud service on top, and I give you a quick overview of that later on. At the moment, there are about 30 full-time engineers working on Gradle. We have quite a momentum, so we just released the Gradle release candidate 1 last week, and going to release candidate 2 pretty soon because I introduced a tiny little bug there. And in general, you want to release every 4 to 6 weeks. We have a steady flow of bringing features in. So there's no big bang release, let's say. So a 4.0 release means that it's more or less for us to cut deprecated stuff out of the code base, etc. Um, so let's take a look of some of those features we worked lately on. Has anybody an idea what that is? That is an island, a Russian island actually, located near St. Petersburg called Kotlin. So now you get what I'm after here. So we worked hard the last year to support a Kotlin-based Gradle DSL. So originally the build.gradle file or settings.gradle file you wrote before only could only be written in Groovy, but now you can do that in Kotlin too. So was the motivation behind that, or what is the motivation behind that? So the current DSL, I name it the current DSL. By that I mean the Groovy DSL. It was not designed for performance, so there are some shortcomings there because we do a lot of dynamic lookups, and it it's it hasn't changed since one of the first Grail versions, I would say. So the other thing is that it was not designed for really tooling friendliness. So one thing I noticed when working with different clients over the last couple of years is that we for a long time we underestimated the need for tooling around build systems. So we invested a lot in BuildShip to bring nice user experience to Eclipse, and IntelliJ is working hard to add good Grail support in IntelliJ. Uh, but then there's something still missing when it comes to editing build scripts. And those those missing aspects here, so it makes it hard to write build scripts or with the in the way you did it for your production code. So there's no so we want to do better here and leverage so the same pattern used to write your production code to write your build scripts. So again, quick management summary, but now about Kotlin. Kotlin is a statically typed language. 1.0 was released in 2016 last year. Now the latest version is I think 1.1.1 or 1.1.0 still. It's driven by pragmatism, which is similar to what we liked about Groovy. It's invented and maintained by the JetBrains guys, and it has, especially in the Android community, considerable uptake. And since Grail is the default build system for Android apps, there's also kind of a benefit here. So we see enticing opportunities here. So we can have proper IDE support with code completion, refactoring, and documentation lookup by having a statically typed language. And it makes it easy to craft DSLs. And since Kotlin offers support or had this use case of DSLs in mind, it's still keeping build scripts clean and declarative. So quick overview, current state, still working closely with the JetBrains guys. Kotlin 1.1 support is in the latest release candidate of Gradle, which is necessary to get that good IDE support. Otherwise, you needed to patch your IntelliJ. Version 0.a of what we call GradleScript Kotlin is in the latest release candidate, so you can expect the release pretty soon. And that's how it looks like. So for those of you who are familiar with that Groovy build scripts, it looks quite similar. So you apply plugin, you configure a convention, you declare your repositories and your dependencies, and you're set. That's all I want to talk about Kotlin now. Other question. So I assume everybody of you is a software engineer. So whose build is too fast? Really? No one? Ah, surprise. And yeah, in general, that's that's one thing with, especially with build scripts or build tools, sorry, that I rarely hear somebody complaining about their builds are too fast. Usually they are too slow. You can do whatever you want. It could always be faster. So we, as Grail engineers, we consider performance really as a feature. And the reason for that is that the performance aspect of your build is significant in because it defines how you use your build. So is your build taking a long time? Usually you don't invoke it that often. So you the usage pattern of your build is quite different. So we think build time is very important. So, and for that we invested in a dedicated performance team. So by that I mean we have a couple of engineers. I think it's now around 6, who really focus on performance work. Um, Originally, we currently focus on 3 aspects. So that's what we're working on now. First aspect is better Android developer experience. So we're pairing up closely with the Google guys to make the developer experience for Android better. And by that I mean improving performance in the Gradle build tool itself, but also working on the Android plugin um, by providing new APIs the new plugin can use to avoid some shortcomings there. Another thing we're currently working on is faster dependency resolution, especially in big builds. That's taking quite a lot of time. I'm not bragging here, but things you can do here is, for example, you can currently working on resolving dependencies in parallel and reducing some of making it in general more performant. And last but not least, there's still uh, space for improvement when it comes to configuration time. So Gradle has that model of configuration and execution time, and the configuration time hits you every time because Gradle needs to configure the whole build because it can execute before it can execute something, and therefore a lower configuration time is what every invocation of a build benefits from actually. Maybe some I think quite impressive numbers what we achieved so far working together with the Android guys. So here you see AGP is an Android Gradle plugin. And Gradle version is a quick overview. So when we started with the last 2.x release, 2.41, and the Android Gradle plugin 2.2, you can see that the configuration time, e.g., if you invoke help, took about 2 minutes for our sample build we used here. I linked that sample build in the link so you can prove those numbers yourself if you like. And if you have one Java change, it took you 1 minute and 15 seconds to change that. With the Gradle 2 or with the plugin 2.3 and the Gradle 3.3, we already improved that significantly. So now it's down to 9 seconds and 29 seconds when it comes to changing one line. But there's a preview out there of the Android Gradle plugin 2.5, and if you're an Android developer, I highly recommend to try that out. And the latest Gradle Nightly, which I think when those numbers are captured was Gradle 3.5 branch. So you can see that one change in a Java class now takes about 6.4 seconds in our example build compared to 2.5. So I think that good numbers, and there's still more to come. So let's leave performance aside and talk a bit about how your build look like. Have you ever, so I'm going to talk about composite builds and I explain what I mean by that in a minute. Have you ever tried to include an external project in your build for debugging? Like you have you have that open source library and you're hunting down that bug and you're wondering, is it my issue? Or it must be in the third party plugin? Or if you or are you who of you is working on who considers working on a big code base or a big project with different modules, etc.? Yeah, have you ever tried to moving separated projects into one big monorepo to make developer life easier, so you don't have to suffer from, oh, I need to check out that project, I need to build it, install it. Then when I install it, I refresh the dependent project, change the dependency to use that locally deployed one into my one instead of the one that got pushed from Nexus or pulled from Nexus. Have you ever tried this? Or who've used writing Gradle plugins? And how do you test your Gradle plugins? It can be a little bit of pain, or it's not that convenient. So, or it hasn't been that convenient. Now there's an easier way to do that, and we name that composite builds. By composite builds, we mean that you can compose multiple builds into one. So we have separate projects, and you can just include that into you have an external project and you can include that into your project here. So how does it work? So there are two ways to do that. One is from the command line by just using dash dash include build and then reference the external project you want to include. Or you can do that persistently by defining a settings.gradle file and have an include build statement here where you say which project you want to have. And that way you can share those settings file and have a persistent setup of your composite build. So maybe let's give it a spin. So here we are. Can demo you something. So I have my Java library, and I have that IntelliJ project here. So you see, I have some dependencies. The one that's interesting is a commons lang dependency here, and in my library class, you can see that I'm using random utils. So now assume I want to change, or I want to test something, a change in that third-party library. So here you can see it's in the random commons lang random utils. So I can't change anything here, right? Does not work. But what can I do? Actually, what I can do is I can say include build and then reference commons lang project. And by that, I import that module, that project as a module. And now if I go here, my library project, and I reference it, I'm now referencing the source in my project. So it's like it would live in my project. And I can easily change the code here. So that's one thing. So really convenient to make a quick change or test something against an external library or a library from another team. Another thing, so testing Gradle plugin. So consider, so in my build script, I use lint, Nebula lint. That's a plugin that allows checking your build for different best practices, let's say. So I say Gradle lint. And here you get some warnings. Not talking too much into this, but those Maven fanboys, I talk a lot to Maven guys, right? And they say, hey, yeah, that's nice, but you have way too much freedom in your build, so you can have if statements in your build script. Oh, I don't want to have that. So what I can do now actually is what I did is I wrote my own lint rule that forbids if statements. Let me quickly rebuild the workspace. I have to download some libraries. Oh, damn it. So the rule, maybe just trust me that the rule is there. And what I do now is I run the lint task. Maybe show it. So there's no if rule where I fail the build if there's an if statement in the build script. And that's only available locally, right? So now the build fails because this build contains one critical lint violation, and here we are, no if, imperative logic must be put into a plugin. So that makes testing your Gradle plugins really easy now. I talked about performance of a build, right? So what is the best way to make your build faster? Or your build tool? The best way to do that is actually to do less. So the less you do, the faster you get. So one thing we introduced with Gradle 3.4 is a better compile avoidance. So we avoid compiling as best as we can to save time. So far we have that up-to-date checks in Gradle that has been there since before Gradle 1.0. So Gradle is a task-based build tool, and if one task notices that its inputs haven't changed since the last invocation and the output is still there untempered, it marks the task as up to date and skips executing, right? That's a huge benefit and brings a lot of improvements. But we can do better when it comes to avoiding compilation. Gradle now detects changes of the binary interface of your dependencies, and that dramatically improves incremental build performance, especially in bigger builds. So maybe let me show that to you. So I have a multi-project build, which is not big for demo purposes, but I want to do an app compile. So that's a multi-project build. Compile Java. Compile Java. So I have three projects here. I want to build app, and app depends on utils, and utils depends on core. So when I run compile Java on that app project, the other projects needs to be compiled too, right? So if I do now, maybe let's look that up. So what I can do now is I change something in the here. So I have a demo app, Gradle run, last name, first name. Interestingly, there's a bug. So it says my first name is R. So let's fix that. It's not my first name, it's my first name. So so we fix that here. So I fix something in the core project. So now the dependency has changed, right? Utils has changed. Do we need to compile app again? Remember the class path has changed, hasn't it? So actually, we need to recompile core, obviously, because we changed the code, but the dependent projects don't need to be updated. And why is that? Because the interfaces haven't changed. So we just changed the implementation. So we can avoid recompiling. So it's different than if we would say we had another public void foo here. Now we change the interface. Now we need to recompile. You see the difference? And especially if you have bigger builds, so we're talking about like LinkedIn, they have multi-project builds with more than 4,000 submodules. You can see how that makes a huge difference in those scenarios. And I think that's a really cool feature and reduces your build cycles quite a lot. There's more Java goodness to come. So we talk about incremental compiler. So we're about to make incremental compiler the default. We invested a lot of that in there. And there's a new Java library plugin, which allows you to create better POMs, to share better, to manage your dependencies better by leaking less class paths. And actually it provides better POMs than Maven. If you want to discuss that later on, just let me know. So now we talked about up-to-date checks a little bit, right? So Gradle reuses the result from the last build and the last time when you run this build on this machine. That's how that up-to-date check works since the early days of Gradle. We think Gradle can do better here. So why not reuse things from any time before when we run any build anywhere? So we currently work on something what we call the build cache. So you can already try that out with -- build cache assemble. And it's an incubating feature, so it's still work in progress, but we like to get your feedback there. So what you can see here is now instead of getting an up-to-date message, you get the message that something comes from your cache. So by default, it's using a local directory here, right? Which doesn't make a huge difference if you just work on one branch or something. But if you switch branches a lot and have maybe checked out different branches, it makes you can already share the same artifacts with, and you don't produce similar artifacts twice in your builds. That already saves you a lot of time. But what will be a game changer, in my opinion, is what we currently working on, as we call it, distributed cache. So what you can do in Gradle, and that works if you want to test that out with the latest Gradle master, you can do that. So you can define a cache in your settings file. You can say, okay, I have a local cache enabled if I'm not CI, but I can have a remote build cache. And I provided the URL and say, okay, do I push to that cache or do I just resolve from that cache? So here, for example, we say, okay, if I'm the CI server is the one who's allowed to push in that cache. And your developers can benefit from it. So you have a nightly build that produces all the artifacts. You come in the morning, run your local build to get your machine set up and ready to work. And you don't need to recompile all that crap because a build server has done that for you and you just reuse that stuff. And that will be a game changer in my opinion. So last but not least, talking about builds. So I talked about builds quite a lot in the last couple of years. And so we noticed that it would be really nice if we could make it easier to collaborate on builds, make it easy to share them and debug issues together. Also it can be quite hard to optimize build performance. And we notice that even I work on Gradle Core. Sometimes it's tricky to find out the hotspots in your build and tweak that and understand where the build time is spent. Um, Also, comparing different build results would be nice and understand why your organization, mm, why builds at one place in your organization maybe behave different or different developers have different results based on whatever their location, their hardware. Um, Comparing builds and gathering those data is essential to make the right decisions, right? And also, wouldn't it be nice to understand how your developers use your builds? Do they use them as you expect them they would use them, or can you give them some hints? Uh, where's the build time going? What should I focus on to make things faster? So that's where we want to introduce Gradle build scans, or that's what we're currently working on. It gives you insights into your build. You can view and share your builds by just copy pasting a URL. Um, Debug and optimize and refine your builds. Communicate by using your builds and analyzing all the builds in your organization, not just the CI builds. Plenty of open source projects already using it. Give it a try. It's available for free at gradle.com. Scans get started. Um, and give us your feedback. We are really interested in that. So that was my talk, or that was my favorite features I wanted to show you and things you can expect from Gradle in the future. Again, if you want to be part of revolutionizing the way software is built, maybe you want to join us. Um, we have all our engineers work remote, so you can do that even from here. Maybe it's a bit tricky with your time zones, but if you are night owl, give it a try, or we figure something out. Yeah, I think I'm open for questions now. Um, Apart from that, thank you. Thanks a lot.